Hello, this is an adaptation of the CarveWright tutorial. Since the original lesson had no audio, Bud is going to assist those of us that like to hear the lesson at hand as well as read the notes. Bud will use a goal pointer and the actual tutorial will use a white arrow. All movement, other than the goal pointer, is done by the original lesson. This lesson is about bit optimization.
Hello, this is Bud. I'm not necessarily going to read every word on each one of these flashcards, but I'll cover the concept and try not to change what the meaning of the basic lesson is about. We're talking about bit optimization, and it's applied to each pattern as a very important concept to understand. There's one very significant parameter that sets the level of carving detail for each pattern, and it's fundamental to how the machine works. The basic concept is as follows. The machine carves and saves 3D images one thin slice at a time from side to side. This is called a raster carving mode. Each of these lines is referred to as a raster line. Each of these lines is a thin slice of the overall pattern and constitutes the trajectory followed by the bit. As each of these lines is carved, the workpiece is moved one raster line width out of the front of the machine, and the next line is carved. This is repeated over and over for each thin slice of the carving. The space between each raster line can be varied between 6/1000ths of an inch to 1/100th of an inch, depending on the quality of the output you select when you upload the pattern. The issue arises because of two bit characteristics. First, the carving bit's width at the tip is 63/100ths, is significantly wider than the space between any two raster lines. The bit width overlaps several lines. That means in order to carve one trajectory, the bit may actually carve away detail in the lines on either side of it. For example, let's say that there was a line drawn on your workpiece with ink, and it was 3/100ths of an inch wide. Now say we command the machine to make one pass right down the middle of that line. The result will be a carved line that is 63/100ths wide, a little more than twice the actual width of the line. It will remove detail on either side of the line. This is actually 10 times the width of any single raster line. In other words, we just potentially obliterated the detail of 9 lines on either side. Secondly, the bit has a taper to it, and as the bit goes deeper into the material, the actual cutting diameter increases. This will increase the effect of the bit for any adjacent lines and vary significantly in depth. The bit optimization function of the software calculates this 3D overlap between raster lines and allows you to dictate how much raster line overlap to allow. It is important to note that the more overlap that you allow, the sharper the detail, but the more obliteration of adjacent raster lines. The reverse holds true for selecting less overlap. Each pattern is very different, and the results of changing the optimization are not always intuitive. We suggest that you always experiment with the bit optimization for each pattern that you lay down. The following example will demonstrate the difference that can be seen by using the different bit optimization settings. To demonstrate, we will use a NASA logo that we imported directly from a graphic. As you can see, the imported graphic has very clean edges. To get the sharp edges in the output carving, it's imperative that you start with a high resolution graphic. By default, every pattern is placed into a workpiece with the bit optimization set to none. We will rotate the piece and zoom in on one detail in particular to demonstrate this option. And we're going to look right in here, I think. I'm going to bring this down so that you can see the entire screen on the computer model that we're working with. And I'm going to click next. And you see the rotation, and you see the line. And you can see the line here, but it's only a real thin line here. It's not this dark, it's just this thin line. That's what they're talking about. With the bit optimization set to none, we see a significant amount of the feature thinning due to the obliteration effect. Let's look back at the original graphic for comparison. See how it is? Now, so with our bit optimization set to none, let's see what happens if we set it to best. This tool can be found under the carving heading in the main menu bar on the carving toolbar, or by clicking the right mouse while hovering over the pattern. Again, I'm going to bring this down so that you see the entire computer screen that we're dealing with, because CarveWright is going to take over the movement. They're going to the carving, going to bit optimization, they're going to best, and now you see that the line has changed. This is it here. Bring it back up so we can read what it says. Notice the change of the width. The relative width is the same. You can see this groove, and that's this continuation right here. I'm going to bring it back down and continue. And what they've done is they've rotated the piece so that you can see it from a top view. Whoops, wait a minute. And you can again see this is that groove right there. That's what they're talking about. And that is the end of the lesson on bit optimization.